Exercise number 38 in section 8.2, and we want to figure out or determine what the general solution to this linear system is. So we'll begin again with finding the eigenvalues, and for that we'll need the matrix A minus lambda I, and that is 1 minus lambda minus 8, 1 minus 3 minus lambda. Now the determinant of A minus lambda I is going to be 1 minus lambda times minus 3 minus lambda minus negative 8 or plus 8. So let's see, we have minus 3 minus lambda plus 3 lambda plus lambda squared plus 8. So we have lambda squared plus 2 lambda plus 5. And I'll use the quadratic here, and I have lambda is equal to minus 2 plus or minus the square root of 2 squared, which is 4, minus 4 times A times C over 2 times A. A is 1. Okay, so this gives me minus 2 over 2 plus or minus. Here I have 20, 4 minus 20, which is minus 16. So the square root of 16 I, or 4I over 2. And I have minus 1 plus or minus 2I. So these are my two eigenvalues. So I will go ahead and let lambda 1 be minus 1 plus 2I. They're complex eigenvalues, so I'm going to go ahead and find my k1, or my vector k, and that is, I have 1 minus 1 plus 2I minus, let me come back here, minus 8, 1 minus 3 minus negative 1 plus 2I times the vector equals 0. So let's see what we get here. We have 1 plus 1, so 2 minus 2I, and that gets multiplied times u, minus 8v gives me 0. Now I could also multiply the second equation and have u minus 2 minus 2I, and that would be multiplied times v, is equal to 0. And I can pick either one of these, since u has coefficient of 1 down in this equation. In the second equation I'll use that one. So u then is equal to 2 plus 2I times v. So if v were 1, then I'd have 2 plus 2I would be u, and thus my eigenvector. In order to write my solution, I need the real part of k1, and that is going to be 2, 1, and then the imaginary part, so this is my b1. My b2 is going to be the imaginary part of k1, and in the top component I have a 2 times I, and in the bottom I have 0 times I. So that becomes my my b2. And then finally, now I can write my general solution, which is going to be x is equal to c1. And now let's see here, I have, let me just write it, b1 cosine of beta, which is 2t, minus b2 sine of 2t, e to the minus t, where alpha is negative 1, and plus c2, and there I have b2 cosine of 2t plus b1 sine of 2t e to the minus t. And that's my general solution in real form.